Hello, everyone. Today we're going to be covering 1.3 scientific thinking and processes. Now, if we were to define science, it's essentially a way of thinking, questioning, and gathering evidence. And the key word here is evidence. So anything that is scientifically proven is usually proven by studies, by research, by data. So it's not based on your opinion, it's based on concrete facts and concrete evidence. By the end of today's lesson, you should be able to list and describe the scientific method, identify the steps of the scientific method, describe and compose an appropriate hypothesis, define and identify the three different kinds of variables, formulate a conclusion, differentiate between the different types of data, and finally, how do you determine if an experiment is valid? Now, just like science, biology involves a process of inquiry. And inquiry, to inquire about something, is essentially to ask questions. All of the experiments that we conduct in biology usually begin with a scientific question. So the idea, the concept of a scientific process is not a new one, and I'm sure that you have gone through this in middle school, perhaps even in elementary school, you were introduced to it. But essentially, the entire scientific process happens because scientists are able to make careful and systematic observations. So they observe something around them in the world, in the natural world around them, and then they start to record their observations, and any recorded piece of observation is known as data. Scientists then form a hypothesis as a possible answer to a scientific question that they might have come up with through their observations and through the collection of their data. And finally, the next step after formulating a hypothesis is basically conducting a scientific experiment. Now, when you are learning about the scientific method, you might not always begin with the observations, right? That's usually something that might happen after the experiment. But the idea here, the reason why I have this cyclical image in front of you is to show you that the idea or the process of inquiry in science is not linear. Yani, you don't have to do a question first and then observations next, and then it doesn't have to be so rigid and so linear. It can be cyclical in the sense that you might sometimes begin with a question. You might sometimes begin with observations. Sometimes you might begin with a pre-existing hypothesis that you want to retest. So the idea is science is a process. It's not something that is so rigid. It's a process, and it can happen at any stage. Now, to make our lives easier, it's important to put things in a sequence, okay? That makes our brain understand things better. So that is why when we talk about the scientific method, we talk about it in steps, right? Just to make our life easier. But it's very important to know that we don't always have to follow these steps in the exact order. Scientists definitely don't do that. So the scientific method, if we were to talk about it in terms of steps, the first step is asking a question, okay, or making an observation. The next is researching the topic. Before you move on to formulate a hypothesis, remember, hypothesis is an educated guess or an educated answer to a scientific question. It needs to be based on some background information, right? So in order to strengthen your hypothesis, you can do some background research on the topic that you might want to experiment about, because someone else might have already dove into and answered your question. So it's always important to look at other references before you move on to the experimentation phase. So next we have formulating a hypothesis. Then you test that hypothesis with an experiment. And then as you're conducting the experiment, you need to collect data. Data is so important. It's so valuable. And the more data you have, the better. Okay. And then finally, after we're done conducting the experiment and having our data, we reach our conclusion, and we have to communicate our results with other people. And that is where the claim evidence reasoning language or strategy that we've been talking about comes into play. It becomes a very scientific way of communicating our results when we do have an experiment. Now, just like I mentioned at the beginning, science is not fixed. We cannot think of science as a rigid process. It's a flexible, it's ever changing. And as we learn more and as technology progresses, we start to change our understanding of the world around us. And we might even change our understanding of science, okay? A lot of the times there are certain theories out there that end up being disproven, and this can only happen through more experiments and more results and more evidence. Again, the key word here is evidence. So what I want you to basically take from this slide is that science is not fixed and it could be changed if new evidence comes about and disproves old, outdated theories. A very good example of this is the theory of spontaneous generation. Spontaneous generation, or like the idea of things. People used to believe that things kind of just came out of nowhere. Okay, so for example, they used to think that whenever they would, you would leave a piece of food out and it would start to rot or go bad. They used to think that the organisms that were making this piece of food go bad essentially just came out of nowhere. Okay, so next we have the experiment phase. So essentially, an experiment usually contains variables. Variables are parts of an experiment that we can manipulate or choose not to manipulate. But essentially, we have the option of controlling or not controlling the parts of this experiment. And these are known as variables, and we have 3 different kinds of variables that you need to be familiar with. The first are the independent variables, and independent variables are variables that can be manipulated or changed. So this is what you can change in an experiment. And in order for an experiment to be considered valid, you need to change only one thing, okay? If you start changing more than one independent variable, that's going to cause a lot of confusion in terms of what caused the results. So that is why it is very important to only have one independent variable only. The second type of variable is the dependent variable, and the dependent variable is a variable that is observed or measured. And this is what basically is being affected by the independent variable. So that's why it's called dependent, because it depends on, or it is affected by, the thing that you change, or the independent variable. And finally, the control variables are the conditions that we keep the same. So these are the conditions that remain the same. We do not change them. And usually what should happen in a valid experiment is that you keep everything the same except for one thing. So you are keeping all the variables exactly the same and only changing the independent variable. Now, the next step after we've identified our variables is to come up with a hypothesis. And a hypothesis is a proposed answer for a scientific question. Now, hypotheses must be specific and must be testable. So what does that mean? It means that the hypothesis, this proposed answer that you have for the scientific question, must be able to be, you can test it. So for example, a hypothesis that is talking about the fact that ghosts exist or not, that's not something that we can test scientifically, right? So that is not a valid hypothesis. It must be something that we can test scientifically, all right? Now, although this is not a concrete, like you don't have to do this, but it is highly recommended that you use the following format when writing a hypothesis. If, and then you list your independent variable, comma, then, and then you list your dependent variable. So please use the following format when writing your hypotheses as a way to guide, a way to guide you in writing a very scientific sounding hypothesis. All right, let's look at an example together. So here it says, a student wanted to see how high an ice cube would float in different temperatures of water. He added the ice cube to 4 different 50 milliliter water cups of different temperatures. So I want you to pause this video and try to identify the 3 types of variables, or sorry, the two variables that are listed here. So independent variable, dependent variable. And then finally, I want you to try to come up with the hypothesis using the correct format. Okay, so hopefully you had a chance to work this out, and hopefully you were able to find that the independent variable here is the different temperatures of water, because that is the thing that we are changing. Okay, so usually what gave this away, these are the words that you want to be looking at when identifying independent variables. So different, right away we can see different temperatures of water. That has to be the independent variable, since that is the thing we are changing. What are we measuring? Okay, what are we measuring? We are measuring the height of the ice cube, how high it would float up. So that has to be our dependent variable. Now, to write the hypothesis, remember, we are following this format. If independent variable, then dependent variable. So now that I've identified the independent and the dependent variables, all I have to do is follow the format. If the temperature of water, and I have to be specific. When you're writing, if you go back to the hypothesis, one of the things about it is it has to be specific. So you can't just say changes. What does that mean, changes? Does it go up? Does it go down? What does that mean? So you have to be very specific. So if the temperature of water, give me a specific word. Increases, decreases, be specific. So I'm going to say increases. If the temperature of water increases, then what's going to happen to the dependent variable? Then the floating height will also increase. Oops. So anyways, as you can see here, we are following the correct format, and it is very specific in terms of what exactly do you predict will happen. Now, the last thing, or the last part of the scientific or one of the last stages, I guess, of the scientific process is formulating a conclusion and communicating a result. So when we are formulating a conclusion, this is the format that you have been using and that we will continue to use this year as well. So please make sure that you follow this format when you are writing your conclusion. And of course, we will have lots of practice on how to do that in the following days. Now, I said that a very important part of an experiment is the data, collecting data, measuring data. But what kind of data can we measure and collect and observe? Well, there's different kinds. The first is quantitative data. And when you hear that word, quantitative, right away we can see that it has kind of the word quantity in it. And whenever we hear the word quantity, what comes to mind is that we are dealing with an amount, right? A quantity is an amount. So therefore, quantitative data includes some form of measurement. So we're going to use an instrument to measure something, whether it be a ruler, a balance, a graduated cylinder, a beaker, a thermometer, etc. Some form of measuring tool is involved, and we're getting results in the form of numbers. So for example, when I say that my height is 170 centimeters, that means that I am using quantitative data. Okay, that is, I'm providing you with the quantitative data. Since I used a meter, okay, to measure my height, and I'm providing you the data as a measurement, 170 centimeters. Qualitative data, on the other hand, is more descriptive, and it uses our five senses. So qualitative data will say things such as how something looks like, how something feels like, tastes like, how it sounds like. So we are using the senses, and it's very descriptive in terms of the quality of an object. So she has brown hair. That is a qualitative observation. For example, the water looks liquidy. That's not very scientific, but you get the idea. It's very qualitative in the way that we're describing the data. All right, and next we have another form, or another two types of ways we can characterize data. They are objective versus subjective data, or types of data. Objective, so right here, objective data means that the data is unbiased, is not controlled by personal feelings, and it's based on facts. It's been verified by scientific studies. Subjective data, right here, is data that is biased. It includes personal feelings and personal opinions, and it's not backed by hard science, meaning it's not backed by scientific studies. It's just based on someone's opinion, all right? So that is why it is so important that when you are doing research to check the resources, to check the references. When you hear something online, when you read something online, or even when you're during your day-to-day life, you're scrolling through Instagram, you read about something, you're on TikTok, you see a video about a topic, make sure you check the references. Is this based on someone's opinion? Is what they're telling you a fact based on scientific studies, or is it just based on their own opinion of the subject? So it's very important to check these things when we are doing research, but also when we are conducting experiments. The last thing I want to be talking about today is, how do you know if an experiment is valid? So when you do conduct an experiment, how do you guarantee that your experiment is valid? I can trust it. The first thing is that it has to have, just like we said, one independent variable only. And you have to control all the other variables. So all the constants, all the other variables must be controlled. The last part of this, checklist in terms of how can we know that an experiment is valid is to make sure that the experiment is testable, right? Just like I was mentioning at the beginning, if the experiment and the hypothesis are untestable, you can't test them, just like, do ghosts exist? That's not an experiment that is testable. So therefore, that cannot be a valid experiment. An experiment is valid if it has one independent variable and also one dependent variable, because remember, those two are tied to one another. All the other variables are controls, and you can actually test it. Okay, so once, like, some terminologies that might be coming, or that you might be hearing besides hypothesis, are theories and laws. Okay, so what is the difference between a hypothesis and a theory and a law? Sometimes they might sound very similar. So a theory is an explanation of a natural phenomena. Okay, so something that is happening around us that we observe, and then we ask ourselves, why is this happening? So usually, when you have a question, you have a scientific question, you form a hypothesis to test it out. Now, if enough people, let's say 100 or 200 scientists or 300, whatever, a large number of scientists and a large number of scientific studies have been conducted, and all of them are supporting the hypothesis, one hypothesis, that hypothesis becomes a theory. So a theory is essentially a hypothesis that was supported by many observations and many experiments over a long period of time. Theories can change and they can be disproven, because as we advance through time and as we advance through technology, we might come up with new forms of maybe experiments or technologies that help us disprove certain theories. On the other hand, laws describe relationships or patterns. They have nothing to do with explaining why things happen. They just tell you that they happen. So a perfect example of the difference between theories and laws is looking at the law of gravity. Okay, so the law of gravity basically was, we all know that it was discovered by Sir Isaac Newton, and it is a law, meaning that he doesn't need to explain how gravity exists or why it exists. He just said gravity exists. And if you don't believe me, you can try jumping from a building and you'll see the effects of that, right? No one's gonna do that, because we will see the effects of gravity in play. Whether we believe it or not, it's there. On the other hand, Einstein, he basically came up with the theory of relativity that explains how gravity happens. Where does it come from? What causes gravity? So as you can see from this example, laws tell us that this thing called gravity exists. Okay, they tell us this is what's happening. It's there. Theories try to explain, why are these things there? Where do they come from? Okay, so I hope that was clear. And that is it for today. Have a good one.